Chapter 1 of Organic Gardeners Composting. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Betsy Bush, in Marquette, Michigan, September 2007. Organic Gardeners Composting by Steve Solomon. Chapter 1. What is compost? Do you know what really happens when things rot? Have other garden books confused you with vague meanings for words like stabilized humus? This book won't. Are you afraid that compost making is a nasty, unpleasant, or difficult process? It isn't. A compost pile is actually a fast-track method of changing crude organic materials into something resembling soil called humus. But the word humus is often misunderstood, along with the words compost and organic matter. And when fundamental ideas like these are not really defined in a person's mind, the whole subject they are a part of may be confused. So this chapter will clarify these basics. Compost making is a simple process. Done properly, it becomes a natural part of your gardening or yard maintenance activities, as much so as mowing the lawn, and making compost does not have to take any more effort than bagging up yard waste. Handling well-made compost is always a pleasant experience. It is easy to disregard compost's vulgar origins because there is no similarity between the good-smelling brown or black crumbly substance dug out of a compost pile and the manure, garbage, leaves, grass clippings, and other waste products from which it began. Precisely defined, composting means enhancing the consumption of crude organic matter by a complex ecology of biological decomposition organisms. As raw organic materials are eaten and re-eaten by many, many tiny organisms from bacteria, the smallest, to earthworms, the largest, their components are gradually altered and recombined. Gardeners often use the terms organic matter, compost, and humus as interchangeable identities, but there are important differences in meaning that need to be explained. This stuff, this organic matter we food gardeners are vitally concerned about, is formed by growing plants that manufacture the substances of life. Most organic molecules are very large, complex assemblies, while inorganic materials are much simpler. Animals can break down, reassemble, and destroy organic matter, but they cannot create it. Only plants can make organic materials like cellulose, proteins, and sugars from inorganic materials derived from soil, air, or water. The elements plants build with include calcium, magnesium, potassium, phosphorus, sodium, sulfur, iron, zinc, cobalt, boron, manganese, molybdenum, carbon, nitrogen, oxygen, and hydrogen. So organic matter from both land and sea plants fuels the entire chain of life from worms to whales. Humans are most familiar with large animals. They rarely consider that the soil is also filled with animal life busily consuming organic matter or each other. Rich earth abounds with single-cell organisms like bacteria, actinomycetes, fungi, protozoa, and rotifers. Soil life forms increase in complexity to microscopic roundworms called nematodes, various kinds of mollusks like snails and slugs, many so tiny the gardener has no idea they are populating the soil. Thousands of almost microscopic soil-dwelling members of the spider family that zoologists call arthropods, the insects in all their profusion and complexity, and of course, certain larger soil animals most of us are familiar with, such as moles. The entire sum of all this organic matter, living plants, decomposing plant materials, and all the animals, living or dead, large and small, is sometimes called biomass. One realistic way to gauge the fertility of any particular soil body is to weigh the amount of biomass it sustains. Humus is a special and very important type of decomposed organic matter. Although scientists have been intently studying humus for a century or more, they still do not know its chemical formula. It is certain that humus does not have a single chemical structure, but is a very complex mixture of similar substances that vary according to the types of organic matter that decayed and the environmental conditions and specific organisms that made the humus. Whatever its varied chemistry, all humus is brown or black, has a fine, crumbly texture, is very lightweight when dry, and smells like fresh earth. It is sponge-like, holding several times its weight in water. Like clay, humus attracts plant nutrients like a magnet, so they aren't so easily washed away by rain or irrigation. Then humus feeds nutrients back to plants. In the words of soil science, this functioning like a storage battery for minerals is called cation exchange capacity. More about that later. Most important, humus is the last stage in the decomposition of organic matter. Once organic matter has become humus, it resists further decomposition. Humus rots slowly. When humus does get broken down by soil microbes, it stops being organic matter and changes back to simple inorganic substances. This ultimate destruction of organic matter is often called nitrification because one of the main substances released is nitrate, that vital fertilizer that makes plants grow green and fast. Probably without realizing it, many non-gardeners have already scuffed up that thin layer of nearly pure humus forming naturally on the forest floor where leaves and needles contact the soil. Most Americans would be repelled by many of the substances that decompose into humus. But, fastidious as we tend to be, most would not be offended to bare-handedly cradle a scoop of humus, raise it to the nose, and take an enjoyable sniff. There seems to be something built into the most primary nature of humans that likes humus. In nature, the formation of humus is a slow and constant process that does not occur in a single step. Plants grow, die, and finally fall to earth where soil-dwelling organisms consume them and each other until eventually there remains no recognizable trace of the original plant. Only a small amount of humus is left, located close to the soil's surface or carried to the depths by burrowing earthworms. Alternately, the growing plants are eaten by animals that do not live in the soil, whose manure falls to the ground, where it comes into contact with soil-dwelling organisms that eat it and each other until there remains no recognizable trace of the original material. A small amount of humus is left, or the animal itself eventually dies and falls to the earth where... Composting artificially accelerates the decomposition of crude organic matter and its recombination into humus. What in nature might take years we can make happen in weeks or months. But compost that seems ready to work into soil may not have quite yet become humus. Though brown and crumbly and good-smelling and well decomposed, it may only have partially rotted. When tilled into soil at that point, compost doesn't act at once like powerful fertilizer and won't immediately contribute to plant growth until it has decomposed further. But if composting is allowed to proceed until virtually all of the organic matter has changed into humus, a great deal of biomass will be reduced to a relatively tiny remainder of a very valuable substance, far more useful than chemical fertilizer. For thousands of years, gardeners and farmers had few fertilizers other than animal manure and compost. These were always considered very valuable substances, and a great deal of lore existed about using them. During the early part of this century, our focus changed to using chemicals. Organic wastes were often considered nuisances with little value. These days, we are rediscovering compost as an agent of soil improvement and also finding out that we must compost organic waste materials to recycle them in an ecologically sound manner. Making compost. The closest analogies to composting I can imagine are concocting similar fermented products like bread, beer, or sauerkraut. But composting is much less demanding. Here I can speak with authority, for during my era of youthful indiscretions, I made home brews good enough to have visitors around my kitchen table most every evening. Now, having reluctantly been instructed in moderation by a liver somewhat bruised from alcohol, I am the family baker who turns out 2 or 3 large rye wheat loaves from freshly ground grain every week without fail. Brew is dicey. Everything must be sterilized and the fermentation must go rapidly in a narrow range of temperatures. Should stray organisms find a home during fermentation, foul flavors and/or terrible hangovers may result. The wise homebrewer starts with the purest and best suited strain of yeast a professional laboratory can supply. Making beer is a process suited to the perfectionist mentality. It must be done just so. Fortunately, with each batch, we use the same malt extracts, the same hops, same yeast, same flavorings, and if we are young and foolish, the same monosaccharides to boost the octane over 6%. But once the formula is found and the materials worked out, batch after batch comes out as desired. So it is with bread making. The ingredients are standardized and repeatable. I can inexpensively buy several bushels of wheat and rye berries at one time, enough to last a year. Each sack from that purchase has the same baking qualities. The minor ingredients that modify my dough's qualities or the bread's flavors are also repeatable. My yeast is always the same. If I use sourdough starter, my individualized bread of wild yeasts remains the same from batch to batch, and I soon learn its nature. My rising oven is always close to the same temperature. When baking, I soon learn to adjust the oven temperature and baking time to produce the same kind of crust and doneness I desire. Perfectionist, yes. I must bake every batch identically if I want the breads to be uniformly good. But not impossibly rigorous, because once I learn my materials and oven, I've got it down pat. Composting is similar, but different and easier. Similar in that decomposition is much like any other fermentation. Different in that the home composter rarely has exactly the same materials to work with from batch to batch, does not need to control the purity and nature of the organisms that will do the actual work of humus formation, and has a broad selection of materials that can go into a batch of compost. Easier because critical and fussy people don't eat or drink compost. The soil does. Soil and most plants will, within broad limits, happily tolerate wide variations in compost quality without complaint. Some composters are very fussy and, much like fine bakers or skilled brewers, take great pains to produce a material exactly to their liking by using complex methods. Usually these are food gardeners with powerful concerns about health, the nutritional quality of the food they grow, and the improved growth of their vegetables. However, there are numerous simpler, less rigorous ways of composting that produce a product nearly as good with much less work. These more basic methods will appeal to the less committed backyard gardener or the homeowner with lawn, shrubs, and perhaps a few flower beds. One unique method suited to handling kitchen garbage, vermicomposting (worms), might appeal even to the ecologically concerned apartment dweller with a few houseplants. An extremely crude composting process. I've been evolving a personally adapted composting system for the past 20 years. I've gone through a number of methods. I've used and then abandoned power chipper shredders, used homemade bins and then switched to crude heaps. I've sheet composted, mulched, and used green manure. I first made compost on a half-acre lot where maintaining a tidy appearance was a reasonable concern. Now living in the country, I don't have to be concerned with what the neighbors think of my heaps because the nearest neighbor's house is 800 feet from my compost area, and I live in the country because I don't much care what my neighbors think. That's why I now compost so crudely. There are a lot of refinements I could use, but don't bother with at this time. I still get fine compost. What follows should be understood as a description of my unique, personal method adapted to my temperament and the climate I live in. I start this book off with such a simple example because I want you to see how completely easy it can be to make perfectly usable compost. I intend this description for inspiration, not emulation. I am a serious food gardener. Starting in spring, I begin to accumulate large quantities of vegetation that demand handling. There are woody stumps and stalks of various members of the cabbage family that usually overwinter in western Oregon's mild winters. These biennials go into bloom by April, and at that point I pull them from the garden with a fair amount of soil adhering to the roots. These rough materials form the bottom layer of a new pile. Since the first principle of abundant living is to produce 2 or 3 times as much as you think you'll need, my overly large garden yields dozens and dozens of such stumps, and still more dozens of uneaten savory cabbages, more dozens of 3-foot-tall Brussels sprout stalks, and cartloads of enormous blooming kale plants. At the same time, from our insulated but unheated garage comes buckets and boxes of sprouting potatoes and cartloads of moldy, uneaten winter squashes. There may be a few crates of last fall's withered apples as well. Sprouting potatoes, mildewed squash, and shriveled apples are spread atop the base of brassica stalks. I grow my own vegetable seed whenever possible, particularly for biennials such as brassicas, beets, and endive. During summer, these generate large quantities of compostable straw after the seed is thrashed. Usually there is a big dry bean patch that also produces a lot of straw. There are vegetable trimmings and large quantities of plant material when old spring-sown beds are finished and the soil is replanted for fall harvest. With the first frost in October, there is a huge amount of garden cleanup. As each of these materials is acquired, it is temporarily placed next to the heap, awaiting the steady outpourings from our 2.5-gallon kitchen compost pail. Our household generates quite a bit of garbage, especially during high summer when we are canning or juicing our crops. But we have no flies or putrid garbage smells coming from the compost pile because as each bucketful is spread over the center of the pile, the garbage is immediately covered by several inches of dried or wilted vegetation and a sprinkling of soil. By October, the heap has become about 6 feet high, 16 feet long, and about 7 feet wide at the base. I've made no attempt to water this pile as it was built, so it is quite dry and has hardly decomposed at all. Soon those winter rains that the maritime Northwest is famous for arrive. From mid-October through mid-April it drizzles almost every day and rains fairly hard on occasion. Some 45 inches of water fall, but the pile is loosely stacked with lots of air spaces within, and much of the vegetation started the winter in a dry, mature form, with a pretty hard bark, or skin, that resists decomposition. Winter days average in the high 40s, so little rotting occurs. Still, by next April most of the pile has become quite wet. Some garbagey parts of it have decomposed significantly, others not at all. Most of it is still quite recognizable, but much of the vegetation has a grayish coating of microorganisms or has begun to turn light brown. Now comes the only 2 really hard hours of compost making effort each year. For a good part of one morning I turn the pile with a manure fork and shovel, constructing a new pile next to the old one. First I peel off the barely rotted outer 4 or 5 inches from the old pile. This makes the base of the new one. Untangling the long stringy grasses, seed stalks, and Brussels sprout stems from the rest can make me sweat and even curse. But fortunately I must stop occasionally to spray water where the material remains dry and catch my wind. Then I rearrange the rest so half-decomposed brassica stumps and other big chunks are placed in the center where the pile will become the hottest and decomposition will proceed most rapidly. As I reform the material, here and there I lightly sprinkle a bit of soil shoveled up from around the original pile. When I finish turning it, the new heap is about 5 feet high, 6 feet across at the bottom, and about 8 feet long. The outside is then covered with a thin layer of crumbly black soil scraped up where the pile had originally stood before I turned it. Using hand tools for most kinds of garden work, like weeding, cultivating, tilling, and turning compost heaps, is not as difficult or nearly as time-consuming as most people think if one has the proper sharp tools. Unfortunately, the knowledge of how to use hand tools has largely disappeared. No one has a farm-bred grandfather to show them how easy it is to use a sharp shovel or how impossibly hard it can be to drive a dull one into the soil. Similarly, weeding with a sharp hoe is effortless and fast. But most new hoes are sold without even a proper bevel ground into the blade, much less with an edge that has been carefully honed. So after working with dull shovels and hoes, many home food growers mistakenly conclude that cultivation is not possible without using a rotary tiller for both tillage and weeding between rows. But instead of an expensive gasoline-powered machine, all they really needed was a little knowledge and a $2 file. Similarly, turning compost can be an impossible, sweat-drenching, back-wrenching chore, or it can be relatively quick and easy. It is very difficult to drive even a sharp shovel into a compost pile. One needs a hay fork, something most people call a pitchfork. The best type for this task has a very long, delicate handle and 4 foot-long, sharp, thin tines. Forks with more than 4 tines grab too much material. If the heap has not rotted very thoroughly and still contains a lot of long, stringy material, a 5 or 6 tine fork will grab too much and require too much strength. Spading forks with 4 wide flat blades don't work well for turning heaps but, en extremis, I'd prefer one to a shovel. Also, there are shovels and then there are shovels. Most gardeners know the difference between a spade and a shovel. They would not try to pick up and toss material with a spade designed only to work straight down and loosen soil. However, did you know that there are design differences in the shape of blade and angle of handle in shovels? The normal combination shovel is made for builders to move piles of sand or small gravel. However, use a combination shovel to scrape up loose, fine compost that a fork won't hold, and you'll quickly have a sore back from bending over so far. Worse, the combination shovel has a decidedly curved blade that won't scrape up very much with each stroke. A better choice is a flat-bladed, square-front shovel designed to lift loose, fine-textured materials from hard surfaces. However, even well sharpened, these tend to stick when they bump into any obstacle. Best is an irrigator's shovel. This is a lightweight tool looking like an ordinary combination shovel, but with a flatter, blunter, rounded blade attached to the handle at a much sharper angle, allowing the user to stand straighter when working. Sharp irrigator's shovels are perfect for scooping up loosened soil and tossing it to one side, for making trenches or furrows in tilled earth, and for scraping up the last bits of a compost heap being turned over. Once turned, my long weathered pile heats up rapidly. It is not as hot as piles can cook, but it does steam on chilly mornings for a few weeks. By mid-June things have cooled. The rains have also ceased, and the heap is getting dry. It has also sagged considerably. Once more I turn the pile, watering it down with a fine mist as I do so. This turning is much easier as the woody brassica stalks are nearly gone. The chunks that remain as visible entities are again put into the new pile's center. Most of the bigger and less decomposed stuff comes from the outside of the old heap. Much of the material has become brown to black in color, and its origins are not recognizable. The heap is now reduced to 4 feet high, 5 feet wide, and about 6 feet long. Again I cover it with a thin layer of soil, and this time put a somewhat brittle recycled sheet of clear plastic over it to hold in the moisture and increase the temperature. Again, the pile briefly heats and then mellows through the summer. In September the heap is finished enough to use. It is about 30 inches high and has been reduced to less than 1/8 of its starting volume 18 months ago. What compost I don't spread during fall is protected with plastic from being leached by winter rainfall and will be used next spring. Elapsed time, 18 to 24 months from start to finish. Total effort, 3 turnings. Quality, very useful. Obviously, my method is acceptable to me because the pile is not easily visible to the residents or neighbors. It also suits a lazy person. It is a very slow system, okay for someone who is not in a hurry to use their compost, but few of my readers live on really rural properties. Hopefully, most of them are not as lazy as I am. At this point, I could recommend alternative, improved methods for making compost, much like cookbook recipes from which the reader could pick and choose. There could be a small backyard recipe, the fast recipe, the apartment recipe, the wintertime recipe, the making compost when you can't make a pile recipes. Instead, I prefer to complement your intelligence and first explore the principles behind composting. I believe that an understanding of basics will enable you to function as a self-determined individual and adapt existing methods, solve problems as they arise, or create something personal and uniquely correct for your situation. End of Chapter 1.